Hi, happy Children's Day to my cutie cutie childrens. Yes, Vasant, tomorrow chocolate getting from me, belated. Today also I sent chocolates for my cutie cutie babies. Ayo, Kanishk, you are joining offline. Bless you all, beta. You joined offline. I was planning because this much chocolate I kept for people. Oh, missed. Ayo. Love you all, beta. Thank you so much. Okay, are you all ready? Come on, start the class. I'm going to start the class. Where is that one kuti monkey, Arunisha? From far, you can see the chocolates. Coochie coochie chocolates you can see and feel happy. These many chocolates, full polythene filled with chocolates. You see, so many chocolates I've kept. Full one polythene full of chocolates. Only chocolates. This is for watching chocolates. Here in coaching distributed chocolates. Come on, beta. Last class, so till now, whatever we have learned, one time we will go for a quick recap because now we will be exactly going to the last phase, last part. Okay. So after this, what we are going to do is we will have last part revision. After that, we will be finishing this chapter. Yes. So all the kuti kuti. Akele, do you know anything about me? Today I am telling. I'm in fast, so I only eat one time a day. I'm not eating chocolates. Aja beta, aja. Where is Arunisha? Where is Tanisha? Where is Kanishk? Where is Sam? Come, beta. Definitely, it's what you call it. It's like a happy moment for me. My children are coming means I'll be always happy. Shall I start? Ayo, I'm going to keep chocolate for you, Kanish. When you are coming means you will be getting. Today Sam coming means Sam I'm going to give. Sam will keep chocolate in his stomach and then he will give you. Where is Sam? He didn't ask any single chocolate. Come on, we'll start the class, please. Now look at it. We discussed from the beginning. We had a full content where we discussed all the things, beta. One by one, just last part we are going to discuss. So we are going to understand the entire section from the beginning one last time. And in that section, what and all is there? We will see what and all we have studied. a quick recap for the content. Okay, so now let's start the chapter. Okay, बीजेपी जिंदाबाद क्यों ऐसा हुआ भाई, क्या किया बीजेपी ने? Now look at it. We discussed about Maharshi Kannad. Okay, we talked about like atoms, wherein people had a conversation like atoms were indestructible, but now atoms will be further broken down as subatomic particle. Understood? Now law of chemical composition. When people discuss law of chemical composition, is law of conservation of mass, law of constant proportion, law of multiple proportion, and law of reciprocal proportion. So these were something different things were there. In that law of conservation of mass was there. In the law of conservation of mass, we learned like the law was first stated by Lavoisier. This part also we have discussed and we have understood that mass can neither be created nor be destroyed. It can only change from one state to another. That was law of conservation of mass, which we have studied. After that, we have seen some examples. With the help of that examples, we have exactly learned how the mass is conserved between reactant and product. After that, law of constant proportion, where we have learned the proportion by mass. Understood? And there we have learned that every atom mass will be exactly participating. Hey, monkey! Aro, for you. Happy Children's Day. Now look at it. After the conclusion sections, we have understood how mass is exactly created and creating problem. After that, we have learned different things. In that part also, we have understood about how many whatever one atom can be exactly two different element can make many different compounds. That part also we have studied, and we have gone through all that ratio part, and then we have learned the Dalton atomic theory. And in Dalton atomic theory, beta, what and all we have studied? We have studied the postulates of Dalton atomic theory. Quickly, my pretty children, inform about the Dalton atomic theory. So, element consists of small indivisible particles called atoms, and atoms take part in chemical reactions. This was we have studied. After that, atom of same element are alike in all respect. Atoms of different element are different in all respect. Atom cannot be created or destroyed. This was the next one. Hi Tanisha, happy Children's Day. Yes, because full one bag of chocolates are there. Dalton theory also explains atoms cannot be created nor be destroyed. Atom combine in fixed small whole number ratio to form molecules. These are exactly the postulates. Merits of Dalton atomic theory also we have discussed, and its demerits also we have discussed. Now last time I'm just discussing the atomic structure. We had a discussion about in that atomic structure part. We have discussed about the structure of atom. Atomic symbols were the second part where we have discussed about and why symbols were exactly removed, and we had discussion about that also. Now after that beta we are exactly we have studied about modern symbol of elements also, like how they are giving the symbols, how they are giving the symbols also we had a discussion about it. Now, if you will see, all the elements were written in the shortcut form, their shortcut symbolic presentation, so that we can be able to write down the chemical equations also in a very simple way. That also we have studied. After that, what better we have done? We have exactly studied about the Latin name and their chemical composition. Many things we have there, and now how the atom exists. We have studied about that either in the atomic form or in the molecular form. That also or in the ionic form. Which one is stable, not stable? That also studied in the previous class. Then we studied about molecules, and then we studied about compounds. So same molecule, whatever molecule made with same element, molecule made with different elements. That's also we have studied. Now, when compound is formed, what is the proportion by mass and how it is exactly working? That also we have finished. After that, HCl and all these contents are already cation and anion. How valency is exactly generated, crisscross rules. This also we have finished, and then names of some of the elements also we discussed. Valency we elaborately studied. After that, we went for nomenclature, how naming is done. That also we have done. So most of the things we have finished. Most of the things we have Okay, so now we are going to go for the next part. Hydrogen is first element in a formula, then no prefix required. That part also we have finished with. So now we are in that situation where we are going to understand the molar concept. Okay, because crisscross rule was the last concept, how to put plus, how to put minus, that we have studied. And now we are going towards, hey, happy Children's Day, beta. This is for Kanish cost. Okay. From Kanish, chocolate that you eat and keep inside your stomach. When he will come. And this is for Kanish. No, you eat. This is my sister. Hi Kanika. Happy Children's Day, beta. Kanish, your chocolate went with Shan. You do one thing. Arunisha chocolate also, Tanisha chocolate also, everyone's chocolate today you eat. Okay. Now look at it. We will go for atomic mass. And in that concept of atomic mass, we have learned a very important thing. And that thing was the first it was about hydrogen. Understood? They tried to about hydrogen, and but for atomic mass, na, an atomic mass of an element is so small that it's see an atom of an element is so small. We will talk about atomic mass in further very details. Beta, you go there and close it, beta. So now how we are going to discuss about it? Just check this one out, beta. So an atom of an element is so small that its mass cannot be determined even with the help of most even with the help of most sensitive balance. Okay, with the help of most sensitive balance also, we cannot be able to find the mass of an atom. It is very, very difficult. Understood? At the same time, gram is too big unit. Yes, so we cannot be able to find the mass of an atom in gram. Correct, na? Because atom mass is very, very small. Understood? So now what we are going to in gram, so it will never come because gram is a bigger unit and atom mass is very, very small. Understood? So what they did is this difficult by introducing the concept of relative mass. Understood? So the concept of relative mass was introduced. What is introduced, beta? The concept of relative mass. The concept of relative mass. So this difficulty was overcome by introducing the concept of relative mass. So initially, hydrogen atom being the lightest was chosen as standard. Understood? So it was lightest. So it was chosen at random. So we were trying to find with the help of by relating. So if two people are standing, in a simple note I'm telling, if two people are standing, one more children is missing, Ruchi. Where is Ruchi? So if two children are there and one is heavy and one is light, one is looking lean and one is thin, then you will say he is fattier than that person. Correct? Na? Why? Because you're comparing two people. Correct? Na? So then you will be able, if you are not able to find the mass accurately, then at least you had a comparison. Understood? So one becomes the standard unit for measuring the weight of the other one. So in the same way, relative mass has been adopted where one atom of an element is used as a standard tool to find the mass of the other one. Understood? To find the mass of the other one. Got it? So the number of times the atom of element is heavier than hydrogen atom was taken its atomic mass. I hope you might have understood better. The number of times the atom of the element is heavier than atom. How many times an element is heavier than hydrogen, that is exactly becoming the atomic mass. That will become what, beta? Its atomic mass. So according to atomic mass could be expressed as atomic mass is mass of atom of element by mass of hydrogen atom. Understood? Mass of atom of element by mass of hydrogen atom. Mass of atom of element by mass of hydrogen atom, and this was the comparison they have generated. Mass of atom of element by mass of hydrogen atom. This is exactly the most important thing. Mass of hydrogen Mass of atom of element and mass of hydrogen atom. Okay, so this is atomic mass. This is exactly about what? This is exactly about atomic mass. So this we have done, and we have discussed about atomic mass. Done. So now in 1961, the most common isotope of carbon. But beta hydrogen na it is single. Hydrogen is what? Single. And hydrogen atomic structure is a single element is there outside, and the structure is very very minute. So it will take these many times we have to multiply and find out. Okay. So what they did is they wanted a more accurate standard to find the mass. Understood? Which can be able to find because hydrogen had some problems. Understood? Its placement problem was there. Its atomic mass was different. Its atomic mass is there. Three different isotopes were there. So many different contents were there, which made them not to use hydrogen as a standard. Then what they used? Carbon. Isotope of carbon. So that means what? Now they used carbon for comparison. Understood? First, whom they were using? Hydrogen. But hydrogen atomic mass, hydrogen was very light, very small. So it was, see, if I want to compare myself with you, means I have to multiply 10 times of me. Then only, if you are 10 kgs, then I am 60 kgs, means what? I have to multiply 6 times. Correct? Now, if you will be 20 kg, then I have to multiply only 3 times. Na? So it will become easier now. So which one is easier? If I will take a more bigger mass. Understood? So they came for a conclusion of using which one? Carbon. Understood? So simple example I have given you. So they used what? They used carbon. Now how they used carbon 12 isotopes? Now same work what hydrogen was doing. Now who is doing? Carbon. Okay. So first hydrogen was doing this work. Now who is using? Carbon. So in 1961, the most common isotope of carbon was chosen as standard and its mass was fixed as 12 unit. How much is the mass fixed? 12 units. So here, so that means what? Chosen as standard and its mass was fixed as how much units? 12 units. Its mass was fixed as how much unit beta? 12 units. So this scale in which relative atomic mass of different atoms are expressed is called as atomic mass unit. What this is called as beta? Atomic mass unit. Scale or AMU. So in that scale where we are finding the relative mass, it's considered as atomic mass unit AMU. What is that? Atomic mass unit. Note down beta quickly that the most common isotope in 1961. In 1961, the most common isotope in 1961. In 1961, the most common isotope of carbon, the most common isotope of carbon was chosen as standard and its mass was fixed as 12 units. What is the mass fixed as? 12 units. So the scale in which relative atomic mass of different atoms are expressed is called as atomic mass unit scale. What it is called as? Atomic mass unit scale. It is considered as what? Atomic mass unit scale. And this atomic mass unit is defined as 1/12 of actual mass of atom of carbon. So if I want to find the atomic mass, how we will find? The atomic mass unit is defined as 1/12 of actual mass of atom of carbon. 1/12 of actual mass of carbon. 1/12 of actual mass of an atom of carbon. 1/12 of actual mass of atom of carbon. How much beta? 1/12 of actual mass of 1/12 of actual mass of atom of carbon. Understood? How much beta? 1/12 of. Is it breaking? Is the voice breaking beta now? So that is the definition. So atomic mass unit is defined as 1/12 of actual mass of atom of carbon. Understood? Note down this one. This is the definition of atomic mass unit. This is the definition of what beta? Atomic mass unit. Okay. Is it okay, beta? Now tell me, is it okay? I checked beta. It is okay now. Now look at beta. So how to go for it? Let's check this one out. Now the number of times the atom of element is heavier than carbon 12 parts. It will become what beta? Atomic mass. How? So relative atom of element by 1 by 12 of mass of carbon, and by this only relative atomic mass is exactly coming, and this will help. So mass of one atom of element, given element, by 1 AMU. This will become, so 1 AMU is defined as 1.6 into 10 to the power. Now is it breaking? 1.6 into 10 to the power minus 12 grams. I'm checking that only beta. Screen is not visible here. Hmm. So what is the definition beta? Relative atomic mass is mass of atom of element by 1/12 of mass of carbon atom. And this will be the way to find. Note down beta. This is the formula. And with the help of this only, we found the atomic mass. With the help of we found the atomic mass. Okay. Let's check this one out. Some days this problem is coming. I'm not understanding what is the problem with this. Now, beta, now check to. Now is it okay? Now live is breaking. Go live and check. It's not breaking for me. No, don't beta. Yes, 1 AMU. Atomic mass unit. It's 1 AMU, that is considered as atomic mass unit. 1 AMU. 1 AMU is atomic mass unit. Understood? So 1 atomic mass unit. Is it not breaking? No, it will not break mostly because I've changed that connection. I changed the connection. Let's see. Little bit okay. After sometimes it is breaking. Yeah, we'll check better. I need to check one time. I'll call that the internet people know. 2 3 days I'm feeling this. Hmm. Now I'll just increase the screen size. Let's see if any break is there. Miss, I'll come to know. Now look at it. So RAM, that is relative atomic mass. Mass of an atom of given element by 1 AMU. This is exactly considered as relative atomic mass. Okay, beta. Now, atomic mass of few common elements. So now we are today going to see the atomic mass. So based on comparing the mass isotope of carbon with another element, we got the relative atomic mass. So you see aluminium atomic mass is 27. Argon atomic mass is 18. So beryllium atomic mass. So these are atomic mass of some of the elements. Understood? So mostly now whenever they will give question, They will not give atomic number, means we know atomic number till 20. Correct now? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphor, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So till 30 done. Correct now? So these are the atomic number. It will go one by one. Correct? So here, like this, it will be going. So that is exactly considered as what? That is considered as what? Atomic number. But mass number will not be similar to that of atomic number. So mass number will be different. Mass number will be what, beta? Different. Okay. So when we will be talking about mass number, how we will be exactly writing that part? Check this one. So mass, now most probably they will write mass. They will write mass. So now they will give you mass. If they want to ask any question from you, means they will give you mass. Now gram atomic mass. First content we are going to study here is gram atomic mass. What is that, beta? Gram atomic mass. So it may be defined as that much quantity of element whose mass in gram is numerically equal to its atomic mass. So that means what? That much quantity of element whose mass will be equal to its gram atomic mass. Understood? So that quantity will be equal to its gram atomic mass. So let's check this one out. Understood. So it will be considered as gram atomic mass, beta. So now let's check this one out. Gram atomic mass. We understood now that is considered as what, beta? Gram atomic mass. Gram atomic mass. Now let's check this one. It may be defined as that much quantity of element whose mass in gram is numerically equal to its atomic mass. Numerically equal to its atomic mass. Okay, now beta? Now gram atomic mass is also as gram atom of the element. What is the other word? Gram atomic mass is also considered as, yes, gram atomic mass is also considered as what, beta? Yes, that's the most crucial thing that we had to discuss. Now we will be going for the next part, beta. Let's talk about the next content. Done, beta? Yeah, gram atomic mass. That is exactly important, and based on that only we are doing. Hmm. Shall we go for the next part, beta? Are we ready for the next one? Very good. So gram atomic mass is also called as 1 gram atom of the element. How much gram atom of the element, beta? 1 gram atom of the element. Now, beta, we are going to check this one out, because how we are going to believe until and unless we are not going to see that one. So now what we are going to check first? 1 gram atoms of hydrogen. Magnesium. So how many gram atoms we are taking? 1 gram atoms of magnesium will become gram atomic mass of magnesium, and it is coming as how much, beta? 24 grams. Understood? Because magnesium atomic mass is how much, beta? Magnesium atomic mass is 24. Correct now? So what we did? We converted 24 AMU into 24 grams. You are understanding? 24 AMU into 24 grams. Are you understanding this part? So here what is here is, you remember this part. It may be defined as that much quantity of elements whose mass in gram is numerically equal to its atomic mass. So what is the atomic mass? 24 AMU. Now what we are doing? We are taking 24 grams. Got it? Instead of 24 AMU is difficult to find now. So what we did? We got 24 grams. So hydrogen 1 AMU. So how much for hydrogen you will take? Very good. 1 gram. Carbon 12 AMU. Then how much gram of carbon you will take? 12 gram. Are you understanding? So rather than writing AMU, we are taking the quantity how much gram? 12 gram. But we should have a very accurate calculating device. Correct now? So now if somebody will say that, yes, if somebody will say that an element atomic mass is 23 AMU, then how much gram you have to take? Very good, super. So that is the most important. Very good, beta. So that is the most important major content. We have converted the atomic mass. Means atomic mass. How much is there? That much grams we are taking. Understood? So if atomic mass of an element is 16, then how much gram of that you will take? 16 grams. Very good. How much you will take? That we will take as 16 grams. So we are getting how much better? We are taking 16 grams. Okay. Now we will go for the next one. So if 2 grams of magnesium will be there, then double of atomic mass. First atomic mass was 24. Now 24 into 2, 48. So next time we will take how much better? 48 grams. So how much gram we will take? 48 grams. So 2 grams atom of magnesium. 2 grams atom of magnesium. 1 gram atom of magnesium is exactly having how many grams? 24 grams. So 2 gram atoms of magnesium will have how much beta? 2 into gram atomic mass. And 2 into gram atomic mass will become 48 grams. Did you understood this concept beta? Yes. This is note down beta. For example, atomic mass of magnesium is 24 AMU. So that means 1 gram will have how much? 24. So 1 gram atoms of magnesium. 1 gram atoms of magnesium will be total how many grams? 24 grams. So 2 gram atom of magnesium will become 2 into 24. How much it will come? 48 grams. From the above discussion, how we are writing? Number of gram atomic mass of element in gram by gram of the element. Note down the formula, it will be very beneficial for you. So write down these two contents, it will always be helpful for you. Hmm. Today is Friday, na beta? Understood, beta? So this is exactly the conclusion of it. Very good. So super. So that means this is the formula. Number of gram atomic mass of element is mass of element in gram by gram GAM of element. Now molecular mass. If somebody will be talking to you about molecular mass. So molecular mass of the substance will be what? It will be defined as average relative mass of molecule of the substance as compared to that of carbon molecule mass. Note down this one beta. This is exactly very important. So molecular mass of substance is defined as average relative mass of the molecule of substance as compared with mass of atom of carbon. Note down this one. Understood, beta? And this one, beta, we have already studied molecular mass is gram relative mass of one molecule by 1 by 12 mass of carbon atom. So already this definition we know. Got it? So molecular mass is average relative mass of one molecule. What is the average relative mass? We have to add up the mass of all the element by 1 by 12 of mass of carbon atom. Understood? Average relative mass means any molecule mass we are going to take out. Like if H2O is there. So H2O, hydrogen and oxygen atomic mass we will add together and then it will become average relative mass of one molecule. One molecule of mass of H2O we will find and then we will write 1 by 12 mass of carbon atom and it will give you molecular mass. It will give you a final molecular mass. Okay. So now gram molecular mass, when the mass will be expressed in grams, it will become gram molecular mass. Write down that definition, beta. That's what. For element is same, molecule is also same. But there in element, we were writing a single one. Here we are writing the total atom. Now look at sodium, sorry, nitrogen, ammonia. In ammonia, how much it will be there? 17 is there. This will be 15 and hydrogen is 3. So total is coming as 17. So 17 grams. How much it is coming as? 17 grams. There we are writing 17 AMU. Here we are writing 17 grams. And if 2 grams we are taking. So 1 gram atomic mass of NH3 is 17 grams. And 2 gram will become how much, beta? 34 grams. Note down this one. And this becomes the formula of it. Note down this one. Yes, beta. That's what. The unit will be 1 gram unit will be divided. Very good. So write down the formula. We will start the next chapter soon. So this part is very, very important. Now formula mass. Formula mass is also considered as by formula how you are exactly going to measure the mass that will become the formula mass. So how we are going to write down this one? Next, check this one out. The sum of atomic mass of all atoms in formula unit will become the formula mass of the substance. Note down, this is the definition of formula mass. This is important. Whatever is important, it is exactly considered as formula mass. The concept of formula mass is applicable only to ionic compound. It will not be applicable to covalent compounds. Understood? It will not be applicable to which compounds, beta? It will not be applicable to covalent compounds. Okay? Then beta. Very good, beta. Super. 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 Shall we go for the next one? Now it is exactly most important. So now let's see how we are finding the formula mass. NaCl. NaCl is the simplest example. So beta NaCl mass is 35.5. Sodium mass is 23. So what is the formula mass? 58.5. In formula mass we are writing U. U means unified mass. Understood? So it has no formula unit mass. It is not having any formula. U will be considered as unified mass. What is the meaning of U? U is considered as unified mass. Note down beta. For formula unit mass, U is considered as unified mass. U is considered as what? Unified mass. U is considered as what? Unified mass. Got it? U will be considered as what? Unified mass. If somebody will be asking you formula mass, then that time you will be talking about the mass of the atomic mass. Hello? Like, message. So the sum of atomic mass of all the element in the formula unit of substance will be called as, and I hope you might have understood this part. The concept of formula mass is applicable only to ionic compound. It will only be applicable to ionic compound. Other than that, it is not at all applicable. I hope you might have understood. Got it? So this is about ionic compound. In the ionic compound, we can use both molecular mass and formula unit mass. Got it? However, for the compound in which ions are not present, the term formula unit mass cannot be used. We cannot use it. I hope you might have understood this one beta. So 58 U will be the answer. 58 U will be the answer. Now beta, if we will be taking like that, then we will talk about NH3. Sodium and nitrogen is exactly how much? 15. Hydrogen is 3. So how much it is coming? 14. So 14 plus 3 will become 17. 14 plus 3. Yes. So now we will solve some questions. How is the formula mass of an ionic substance calculated? Now we are going to calculate. So how is the formula mass of an ionic substance calculated? How we are going to calculate it? The formula mass of any ionic compound is expressed as sum of atomic mass of all the atom present in the formula. Understood? Like hydrogen, see how much is there? One only. Understood? So one atomic mass of sodium, one atomic mass of chlorine. So sodium atomic mass is 23U, chlorine atomic mass is 35.5. So total it is calculated as 58.5U, and this is considered as formula. So molecular mass or empirical formula mass of substance is equal to sum of the atomic mass of all the element. So sum only we are finding. Like look here, magnesium chloride. How we will do magnesium? One unit is one magnesium is there. So 24U. 2 chlorine is there. So 2 into 35.5. How much it will become? 95U. Come on, go for this aluminium. Aluminium atomic mass is 27. How many aluminium is there? 2. So how much it will become? 54. Oxygen is how many? 3. So 3 into 16 will become 48. Note down this. So this will become 102. Yes. Now we will find, calculate the molar mass of the following substance. We can calculate and find beta. Let's check this one out. We will calculate and find. Let's check this one out. Ethene. Carbon is having how much beta? Carbon is having 12. So 12 into 2 plus hydrogen is having 1. 1 into 6. So 24 plus 6, it is coming as TU. Correct? Easy. Now again for C2H2 also we can find how much it is coming. 12 into 2, 2 into 1. Now note down quickly, note down. And then sulfur molecule. Sulfur atomic mass is 32, 32 into 8 is 256 U. Then beta, for phosphorus 4 into 31. Understood. Now beta, calculate the mass. Now we will solve the numericals. Children, are you ready? No, beta. Calculate the mass of 0.72 grams. Now, how we are going to do? 0.72 gram molecular mass of carbon dioxide. First, though, we will find molecular mass of carbon dioxide. 12 plus 12 into 1 carbon and oxygen is how much? 2. 2 into 16. So, 12 plus 32. Total it is coming how much beta? 44 gram. So 1 gram molecule is this much, but they are telling this much gram. Okay. So when 1 gram is having 44 grams, 1 gram molecule of this much is having how much? 44 grams. So that means how much gram they are asking? 0.72 will be how much beta? So we will divide it by 0. Multiply it with 0.72. So 1 gram is this much. So 0.72 gram will be how much? 0.72 into 44 gram. Got it? So it will come how much beta? After solving it is coming 31.68 gram. It is just like beta, one chocolate cost 44 rupees. So these many chocolate will cost this much into 44. Understood? This is the simple numerical questions. Yes beta. Please do it. Do it this one. Yes, this is numerical part, but 100% people will be able to do numericals. It's good only. So 0.72 gram molecule of CO2 will become 44 gram into 0.72 gram, 0.72 gram. The total gram is coming as 31.68. Total gram is coming as 31.68. Got it? So it is coming how much beta? Yes. Finished? Super. So this is coming as how much beta? 31.68 grams. It is coming as how much? 31.68 grams. Okay. We'll go for the next one beta. Completed? Super. So mole concept. Now we are going to start mole concept. Mole concept. Beta, before starting mole concept is there or not? I think mole concept is not there. Formula, your atomic mass is there and molar mass is there. But mole concept is not there in your syllabus. Can you tell me if mole concept is there? Then I will start. Otherwise, I will not start mole concept. Beta, can you tell me quickly mole concept is there or not? Wait, you have sent me the screenshot of the chapter now. Okay, then this much is the last part of the chapter. So we have finished atoms and molecules. Yes, so most major part, molecular formula and everything we have done. Okay, beta? Okay? Yes. So next class, beta, we will be going.